the next workshop, which I'm gonna assign soon, is setting up your calculator so you learn how to do systems of equations. What I'm gonna do right here is I'm gonna show you the nomenclature, how you set it up. So, we have two equations, two unknowns. So we are gonna set up a 2x2 matrix. So, I'm just gonna go like this. So these dots really shouldn't be there, right? What kind of matrix is this? A 2x2. What does the first one represent? Rows or columns? Rows. So what is this? 2 by 1. 2 rows, 1 column. What about this? 2 by 1. The first row represents equation number 1, which is what this is. This right here is equation number 1. This is equation number 2. The first column represents one of the variables, and the second column represents the second variable. Since the first variable is TA, this right in here is called TA. If the second variable is S, S goes right here. So look up when you're finished writing. So what goes in here are the coefficients in front of these variables. So watch me for a minute. For equation 1, what coefficient gets multiplied by TA and what coefficient gets multiplied by S? So TA's coefficient is negative 0.4226. And this one is negative 0.866. And here's our equal sign. Everybody sees this? So watch how I'm doing this. Negative 4226, look up here. Negative 4226 times TA plus negative 866 times S is equal to, what does that equation tell me it's equal to? 0. So now fill in what the second row would be, which is equation number 2. Okay, what goes in the second one? 9063, negative 0.5 equals 1,000. And now I'm going to get rid of these dashes because you really aren't supposed to have those in there. So you could say in your calculator, this is matrix A, and it happens to be a 2x2, and then the calculator will ask what these numbers are. And the next matrix is B, and it's a 2x1, and you're going to be solving for that one. This is the one that's the unknown. And then this is matrix C, which is a 2x1, and you know what the values are. So what are we doing? We're multiplying this matrix by this is matrix multiplication, equals C. And we're solving for B. So matrix B is equal to what? Matrix C divided by matrix A. And how your calculator wants to see it is matrix B is equal to the inverse of matrix A times the matrix C. Okay, I know it's confusing, so let's just, don't look at the calculators for now. So, you're going to tell the calculator, hey, matrix A is going to be a 2 by 2, and then it's going to say, well, what's in it? And you plug it in. Then they say, well, what do you want for C? And you say, oh, it's a 2 by 1, and you plug these in. And then you do this matrix function where you say inverse of A times C, and it'll pop out matrix B, which will be the values of these. But I would say the easiest way to do it on a calculator is to plug in the two systems of equations. That's the easiest. Okay. So let's finish the statics part. TA comes out to be equal to 869.1 pounds, and S turns out to be negative 424.2 pounds. So go back to the picture, the free body diagram. Don't do the matrix stuff, please. Concentrate on this. Why did you get a negative here? Why, do you think? Because you had put it in the wrong direction. Is that bad to get a negative? Nope, not at all. Because you have your free body diagram that shows S is going down to the left, and then you have a negative. So the person, your answer, the solution to the problem is the free body diagram and the values you got. So somebody who's reading this says, oh, they drew TA going up, they got a positive, oh, it's 869.1 pounds going up. Then they look at us and say, oh, the person drew it down to the left. They got a value of 424.2 pounds, but then there's a negative, so it means that S really goes up. Do you redraw your free body diagram? No, because your solution is the free body diagram you drew and the values you got. They go together. So that means anytime we assume the wrong direction, what are we going to get in our answer? A negative. Clara?
Didn't you say at some point you're not going to be able to look at the picture and tell whether it's compression or tension? So I guess in this case I can understand how the negative would be the wrong direction, but what happens if you have no idea if it's compression or tension, it's just a force?
So you just make an assumption, and we're going to see that in a few weeks, actually probably more like 5 weeks, where you're just going to make an assumption that it's going one way or the other, and then you're going to get a positive or a negative. Think of connections. All connections on parts. Like there are pins in here and there are nails and stuff. Some of them are taking tension and some are taking compression. Oh, think of a truss. A truss, could everybody picture a truss? It's a bunch of triangular, members together. Some of those members are taking tension, some are taking compression. And when you look at it, you have no idea which one's in tension or compression. So you're going to make an assumption and you're going to say, oh, this one's going, I'm going to assume that this one's going this way and this one's going this way. And then when you get a positive or a negative, that tells you what the direction is. Many times what's standard is you just draw it in the positive direction. And then when you get a negative, it's in the negative direction. But you can draw it any way you want. Okay? So early on, I'm introducing to you a situation where you really knew which direction it was supposed to be in, but we assumed the wrong direction so we could see what we would get in our answer. Santiago?
I'm a little bit confused by the minus sign because you drew the force going down to the left. So down to the left is negative, and we're getting a negative.
Okay, good question. So we drew it down to the left. Remember, there's magnitude and direction, right? So when we drew S down to the left, we accounted for that with a negative X value and a negative Y. So we already accounted for the direction that was proposed. This is a negative, if you want to think of it as a negative magnitude. When you get a negative magnitude, it means it's going the other way. Because notice, that is only a magnitude value, right? It's this part that gives you the direction. T is a positive. T happened to be going in the negative direction too. So that's a positive magnitude is just confirming the direction you drew. A negative magnitude is saying you drew it in the wrong direction. Good question to clarify. Okay? Yeah?
So it's okay for us to leave the negative sign?
Now you leave it. You're done. You're done. You are showing me a free body diagram. You're showing me that you got negatives. We're done. And it's new to you now, but 2/3 through the course, you're going to be getting negatives all the time because we never know which way it goes. Okay. So let's look at the syllabus and just figure out where we are. Let's look at the workshops first. Okay, so workshop 4 is 3x3 matrices and showing how to use it on your calculator. Okay, so that's going to be due a week from today. Is today the 5th?
Yeah.
So 12. We're not doing 4 and 6 yet. So did everybody get that? Workshop number 5 is due on the 12th. What I would like to do is I don't want you to do all the problems yet, but I'm going to tell you, because we haven't done a lot of problems, but we have done a lot of setup. So I want you to set up each one of these problems. And what does that mean? 1 page per problem. 1 page per problem, because you're going to come back and finish the problem. Right? You are doing steps 1 through 7 for those problems. We still have all the math crunching to do. So set up, so how many problems are there? 7, 14, 1, 2, 3, 4, 5, 6, 7. So you have 7 problems, you're going to have 7 sheets of paper, and you're setting up all 7 of those problems. Okay. Well, on Tuesday, I'm going to assign to do the whole problem. Well, then let me just do this. Let's say that if the whole thing is due on Thursday. But right now, you could do all the setups. So the statics, the whole problems will be due a week from today, but you could do the setups by Tuesday. I wouldn't wait, it's fresh in your mind now. Do the setups now. Chelsea?
If we feel comfortable, can we do the whole thing or do?
I would rather you not, because it's going to take you a while to do the setups. I would rather you do all 7 setups because it's going to take a while. And then the number crunching, because I'd like to show some examples of ways to solve things that'll make it a little bit easier. Okay? Okay.
Do the setups by Tuesday?
I suggest doing the setups by Tuesday.
But we don't turn it in on.
You don't turn it in. Do the setups by Tuesday so you're ahead. Or not that you're ahead, so that you're on par with what I'm doing. Chelsea?
And we're gonna have a quiz on Tuesday.
And we have a quiz on Tuesday. Good question. I'm glad you asked. The quiz on Tuesday will be a setup problem. I'll give you a 2D problem that you have to set up. Okay, so doing the setups by Tuesday will help you study for the quiz. And I just sent you the solutions of those problems this morning.